This is section 1.5, part A, parent functions and transformations. In this section, you should be able to identify, graph, and describe parent functions, and you should be able to identify and graph transformations of parent functions. So a parent function is just the simplest form of the function in a family of functions. The first type of parent function is the constant function. This is just a function of the form f of x is equal to c, where c can be any real number. If c is equal to 0, then we say it is a zero function, and it would be a straight line that is also the horizontal axis. The identity function will be a straight line that starts at the origin and has a slope of 1, so it's going to be f of x is equal to x. This function is going to contain any coordinate of a. So if my x value is 1, my y value is 1. If my x value is -5, the y value would also be -5. The quadratic function is f of x is equal to x squared. The cubic function is f of x is equal to x cubed. This function is symmetric about the origin. We have the square root function. F of x is just the square root of x. The reciprocal function is f of x is equal to 1 over x. The absolute value function is just the absolute value of x. When we're dealing with the absolute value of x, if x is less than 0, you're actually going to use the function of -x. And if x is greater than or equal to 0, the function is just x. We have a step function. This is a piecewise function that's defined by a function in which each graph resembles a set of stairs. One type of step function is the greatest integer function. You're going to denote this with these square brackets around the x. So f of x is equal to x inside those square brackets. And it's defined as the greatest integer less than or equal to x. So if we look at a value of 1.5, the integer that is less than or equal to that would be 1. So if we go to the graph, if we're at 1.5 for our x value, which would be here, if we go up, it's going to have a y value of 1. Anything between 1 and 2 will have that value. But once we get to 2, we are jumping up to 2. We go over, it's open at 3, and then we jump up to 3. So the first thing you're going to do is you're going to describe the characteristics of the parent function. You're going to state its domain, range, intercepts, the symmetry, continuity, and behavior, and intervals in which the graph is increasing or decreasing. So you first have to picture what the parent function graph looks like. This is the graph of the square root of x. So the first thing we're going to do is we're going to find the domain. Remember the domain, you are looking from left to right to see which x values you will have corresponding y values for. So our domain in this case, the first x value we have is when x is 0. And we have all the values to the right. We do know we have x is 0 because that's a closed circle. So this is going to be a square bracket. And we're moving to the right, so it's going to positive infinity. Our range, remember you're moving from the bottom of the graph to the top of the graph. So our range, again, our first value is when when our y value is 0. We know that we have that 0 because it is a closed circle, so that is a square bracket. And then it goes up forever, so that is infinity. Next, we need to talk about the intercepts. Not all graphs will have intercepts. If the graph does not cross the x-axis, or if the graph does not cross the y-axis, you would just say there are no intercepts. In this case, we have one intercept, and that's where it's crossing the x and the y-axis. So we have an x-intercept of 0 and a y-intercept of 0. Next, we're going to look and see if there's any symmetry. Remember, you can be symmetric about the x-axis, symmetric about the y-axis, or symmetric about the origin. You are symmetric about the x-axis if you can fold the graph over the x-axis and the top half matches the bottom half. There is no bottom half in this case, so that is not symmetric about the x. You're symmetric about the y if you can fold the two halves across the y-axis and the right half will match up and look exactly like the left half when they meet. There's nothing on the left side, so we're not symmetric about the y. You're symmetric about the origin if you can take the object and rotate it 180 degrees around the origin, and it still looks exactly the same. This only has information in quadrant 1, so we cannot rotate it and still have it look the same. So this graph has no symmetry. Continuity just means, can I draw the graph without picking up my pencil? For all the values of our domain, or all the x values, we do have a corresponding y value. So this graph is continuous for all values of the domain. Next, they ask us to talk about the end behavior. We can look at the left side and the right side. Some graphs will have behaviors on both sides, but not all of them. If we look at this graph, it has a starting point of x, so there is no end behavior on the left side of our graph. So we're going to just say that the graph begins at x is equal to 0. But we will have to have an end behavior for the right side of this graph. So the limit as x is approaching positive infinity of our function. So if we look at the right side of this graph, it is continuously growing higher. It's at a slow rate, but it's still going to go up. Your end behavior can be positive infinity if it's going up forever, negative infinity if it's going down forever, or it can be approaching a specific value, and then you would tell me what that value is. But since this is going up forever, this is positive infinity. The last thing we need to do is say where this graph is increasing or decreasing. In this graph, from x value of 0 to the x value of infinity, this is increasing. Transformations of parent functions can affect the appearance of the parent function. We can have rigid transformations, or we can have non-rigid transformations. A rigid transformation changes the position of the graph, but changes the size and the shape of it, keeps it the way it is. A non-rigid transformation will distort the shape of a graph. So our first rigid transformation is going to be a translation. Remember, a translation just moves a graph, so it's going to slide it or shift the graph left or right or up and down. We know it has a horizontal shift if it shifts the graph left or right, and it has a vertical shift if it shifts it up or down. When we're dealing with our function, the center of your graph on a parent function is at 0, 0. If we are translating it, we're going to move it left or right or up or down. The x minus h plus k is going to tell us how we're translating it. The center of your graph is going to be located at h and k. So anything that is added or subtracted to the x, whether it's inside a square root, inside an absolute value, inside parentheses, when you pull it out of the parentheses or put it back into the parentheses, you will be changing the sign. So if we take a look at this function, we need to graph the function. First, let's identify what the parent function is. Our parent function is f of x is the absolute value of x. If we were to graph this, it starts at 0, 0. It has a slope of 1 and on the right side, and a slope of -1 on the left side. Now this tells me I'm going to take my function, I'm going to add 4 to it. Since the 4 is outside of the function is the absolute value. If it's outside, it's not attached to the x directly. It means I'm talking about the whole function or the y value. So you're shifting the y. Y is up and down. So this is going to tell me to shift up 4 units. So we're going to take our center of our graph. We're going to shift it up 4 units. So instead of being at 0, 0, it's going to be at 0, 4. Everything else about the graph is going to stay exactly the same. On the left side, we still have a slope of -1. On the right side, we still have a slope of +1. So if the value is attached to the x, then it's going to be horizontal. If it's outside of the function, it's on the whole function, so it's dealing with the y. If we look at this example, this time we do have a value inside that absolute value and one outside. Let's first graph that parent function. Our parent function still is just the absolute value. Now we need to find the center. When you are finding the center, when you pull stuff out of an absolute value or a square root or parentheses, when you're finding the center, you do change the sign. So when we pull that 2 out, it's going to become a +2. The -1 will still remain negative. So our center of our absolute value function will now shift over. It'll be at +2, -1. So our center will be right here. The slope is still going to remain the same. It's still going to have a slope of 1 on the right and -1 on the left. A reflection is a rigid transformation that produces a mirror image of the graph of a function with respect to a specific line. Now we can reflect across any line, but we're going to look at a couple specific ones. If we reflect across the x-axis, to do this, it's just going to be the negative of the entire function. So the negative will be outside of the parent function. If we want to reflect across the y-axis, that negative sign is going to be inside the parent function and only be on the x. So if the negative is on the x, reflect across the y. If the negative is on the y, it's in front of the whole parent function, then you reflect across the x. You do need to be careful on where that negative sign is located and if there are any parentheses. If we look at the example at the top, the first thing we are going to do is we're going to reflect it across the x-axis. So our original figure would have looked like this. Because of the order of operations, we deal with stuff outside the parentheses of the square root first. So we would have reflected it across the x-axis first. Then we would have taken the graph and shifted the center to the to the right 1, because when we pull that out, it's going to become +1, and then up 2, and that's how they got this final graph. But the one underneath of it, that negative sign is out front. Order of operation tells us we have to work inside the parentheses first. So if our original function started here, order of operations tells us we would translate first, because that's inside the parentheses. So we would move the graph 1 unit to the right and 2 units down, and it would go this direction. And then, because the negative sign's out front, then you would reflect it. So it would come this direction. So it is important, I'm sorry, I graphed that wrong. We would go, for the second step, we would go 1 to the right and 2 up. That graph would go here. Then you would reflect it across the x, and that would land down here. So the order in which you do things is important. You need to pay attention where that negative is located. So we need to describe how this graph is related to the graph of x squared, and then we're going to write an equation for the graph. Remember, the graph of x squared starts at 0, 0, and it's flipped up. So obviously, they reflected this across the x-axis. After they reflected it, it would have ended up down here. Then they took that graph and they shifted it to the right 1, 2.5 units. Now when we go to write our equation, since it's reflected across the x, we put the negative in front of the y, or in front of the entire equation. Remember, our parent function is f of x is equal to x squared. So if we want to put it in front of the entire function, we're going to put it in front of that x. And then with the x is where we put the 2.5. Remember, it's inside the parentheses, so we do need to change the sign. So when we put it inside the parentheses, it will become negative. So our equation is going to be g of x is equal to negative x minus 2.5 squared. If we look at one more example of this, our original function is still the squared, x squared. The first thing they did was they reflected this across the x-axis. So our graph is going to change and come down here. So the first thing they did was put a negative sign out in front of that whole function. It's in front of the x squared. It's not just on the x inside the parentheses. Then they took the graph and they shifted it up 2 units. You're shifting it on the y, so it's outside, it's not on the x. We're shifting it up 2. So our g of x is negative x squared plus 2. If we describe this, again we said it's reflected across the x-axis. And then they shifted it up 2 units.